Fine arts. Built in this classical way. It was innovated about 5,000 students, so it's a quite big activity. Courses are most of our courses that are taking up the last quarter. Years. So, as academics, actually, academic discussion and open debate. It's for me, it's I would say amazing activity called the Institute. Just to it's a physical place, it's a house. Researchers can gather typically for 1 day per week during a year to really deeply discuss these topics, and that's an interesting way to widen and increasing the knowledge about what we want to do in the research area. And myself, I participated in a water research activity at Persson for 11 years ago, and that more or less led to what I have here. When it comes to research, we're active with PhD students at all faculties. We have about 770 professors and 4,400 other academic staff, and a yearly output of about 6,000. Education that is done is also closely related to the society, and one activity to reach and to inspire high school students, but also primary school students, to pupils to realize that higher education can be a fantastic, inspiring, exciting way, is the water hall, Vattenhallen. It's a science center where students help and perform experiments together with both primary school students and in some cases also high school students. We're happy to say that the setting in Lund and the way how the Lund University has evolved together with the city of Lund has made the place a very pleasant, attractive place for students, and we also yearly attract more international students than any other university in Sweden. And this is one example why it's quite fun to also be student. It's a so-called carnival. Every 4th year there's a carnival arranged by the student associations, where the city is turned into a festival area for 4 days. Yeah, very close to Lund is located in Malmö, and there is close collaboration with the cities of Lund, Malmö, and Helsingborg. Also, of course, very proud of the presence of university in the cities. And maybe you can't see it, but you have Copenhagen here, Denmark, and you have Sweden, Finland, Estonia, Latvia, Lithuania, Poland, and Germany. And Lund is located here, where it's very well located in the what we call the Greater Copenhagen area, where there's actually a substantial amount of researchers, students, research parks, and education institutions, which means that it's possible to have a close collaboration with other universities in the area, and also have close collaboration with research outputs like spin-off companies and different kind of venture capital investors. We are happy to say that there are two special world-class research facilities located in Lund. This is the MAX4 synchrotron source to generate different kinds of X-ray radiation that can be used for investigating the properties of material. And then we have, maybe don't really see it, but a spallation source, ESS, European spallation source, that produces neutron scattering with the help of electron accelerators. So it's about 450-meter long accelerator that hits wolfram at a tungsten area where neutrons are released. And this scattering of neutrons makes it possible to see the positions of hydrogen atoms in, for instance, water or other materials where the hydrogen is present. So this is the biggest, so far what we know, the biggest spallation source in the world, and unfortunately it's not ready in operation. The MAX4 has been in operation for about, this one. MAX4 has been in operation for about 3 years and generates research papers every week, I would say. ESS will probably be taken into operation 2025, but it's under construction now. And then there's the city around. And a little bit, maybe you have been into contact with the artificial kidney, the diagnostic ultrasound, very much used to see the soft tissues inside bodies. Nicorette, that's nicotine gum to help people to quit smoking. Yeah, and there are a number of innovations. Actually, I don't really understand why I didn't put up Bluetooth, because the Bluetooth system that is also developed in Lund, and much of the mobile cell phone technology, ultrasound. Yeah, okay, here we have Bluetooth. So it's a vibrant, I would say, vibrant research environment with a lot of skilled people and a lot of interesting companies, and also good support from the regional and the local authorities, and to some extent also good support from the government itself. And that is leads us to the question, what is the water research doing in this network? Well, at Lund University, we have a number of divisions and departments working with water research in actually more or less all the faculties. Maybe not full divisions in faculties of humanities or economics, but at least researchers active in it. But at the Faculty of Science and Faculty of Engineering, we have several researchers working in divisions. At our division is the biggest, the one I mentioned, Water Resources Engineering, and we have 22 professors and researchers and about 20 PhD students. We teach about 460 students and 102 actually PhD defenses since 73. Publish around 100 papers per year, and have a turnover of 29 million Swedish crowns, that is roughly a little bit less than 3 million euros, or around $3 million. We are active in all aspects of water research where water is in nature or society. So, of course, hydrology, the classic hydrology, understanding how the rain generates, flows to rivers and collects in lakes, and how that transports to finally to the rivers, to the outlet, to the sea. A special part of hydrology is the coastal processes, how erosion, how waves, how particle transport affects the stability of coasts, and erodes or builds up depending on how the situation looks like in the specific coastal area. Classic hydraulics, of course, what happens with physics when it transports energy in water. Water quality is very central, and we have water quality in sense of chemical, physical quality, but also a quite big group working with microbiological quality. Utilizing different sequencing techniques for DNA. There has been some interesting papers presenting the stability in the biofilm inside the drinking water pipe, and also in the treatment process in a drinking water treatment plant. How does the biofilm on the surfaces of particles of sand grains used for filtration of water, how does these different biofilms change depending on conditions in the feeding water, the source water, and also what kind of operations inside the treatment plant that generates. I mean, we can maybe, by having a high backwashing, remove some of biofilm, and that can affect the stability of the filtration process after the filtration backwashing step and so forth. And as you will learn here today, quite impressive work in the remote sensing, which Hossein will present much better, and also working with these integrative aspects of these problems related to water management. Because as engineers, we like to approach the problem with an engineering toolbox and doing calculations, doing dimension designs and so forth. And that is, of course, very good. And we are very proud of the work and the quality. But once we start talking with the stakeholders, people outside the academia, they also must feel that the suggestions that we come with are relevant and are good for them. It's not sufficient just to say that this is what we have decided is the best for you. We also need to listen to what the farmers, representatives from authorities, conservation biologists working with conservation of land, and school teachers, different politicians, businesses. I mean, all these people use water. We need water. Our simple consumption of food and clothes requires a fresh water feed, as you know, this water footprint. We use something between 2,000 liters up to 4,000 liters of water. We need about 2,000 to 4,000 liters of water per day to meet the consumption that we do. We also use around 100, a little bit more than 100 liters per person a day, just to keep ourselves healthy, fresh, flush out residuals from when we have to go to the toilet, prepare coffee, tea, and food. It's an amazing amount of fresh water needed every day to meet our consumption needs. And unfortunately, with growing income, we tend to consume more. So we tend to use more and more resources. And that, in combination with a development in the society, that we have a population increase. We get more people on the globe. So richer people consume more water, and more people consume more water. So yeah, how can we get this exciting equation to be balanced? Because we need to do that. We need to have a resource management so that the water is meeting the demands also in the future, not only what we have today. And that's why this integrated water resource management, Christian will talk much more about it, but that's why it's a very relevant area also to dive into and to understand better. Okay, a little bit about, we have, as you see, we are lots of people, so lots of programs and research activities. But one very interesting program is called Water Agri. It's funded by the Horizon, European Union Horizon program. It's about 7 million euros. It's collaboration with 22 universities and research institutes in Europe. And the idea is to understand both how does the amount of fresh water available for agriculture affect the crop yields, and how can different measures on the land be used to reduce evaporation, increase the uptake of water for the plants, and also using remote sensing, understanding what are the available resources present in a specific landscape at that time when the farmers need the water, and how can that information be transferred to the farmers and utilized for their efficiency, increase of water management. One thing that is we are very proud of, well, we brag about everything, of course, but the water research schools that we have, it started 7 years ago in a smaller scale, and now we are joining together all the universities in Sweden that have advanced water teaching. So their PhD students are offered to participate in a water research school program. So we gather the students and together with the other universities, so all the way at Stockholm and up in the north, Gothenburg, and so different universities. And we offer based on the season, based on the semesters, offer courses in aspects of water research. And now it has been a success. So we got an extra funding. So we will have actually 6 PhD students working specifically with the water research school topics. It's called AquaClim, in combination with a general water research school activities. A wonderful program on monitoring. It's called LEAP in Swedish, freshwater monitoring for water supply risk mitigation. It's funds also from a governmental research institute, FORMAS, looking into resources. I think, Hossein, will you go into it at all, or no? I mean, it's going from remote sensing information on land use and water availability over analysis of how these conditions look like in the different observed places from the satellite, and then interpreting that into variations in water availability. So it's a quite nice program, and there will be 3 PhD students employed at 3 different universities, and it's run from Lund by Hossein. This is just an example of the width of the big variation in PhD topics that are offered from our division. So these are the latest PhD students when they graduated, and these are the titles of their theses. So these are just, as you saw, we have 102 theses presented the last 50 years, but these are the ones from late 21, 22, and 23. So just for instance, we have one example on water management, efficient management of water utilities, sustainability analysis of Swedish performance, done by Nasik Nayar, who has investigated the quality of utilities of the municipal. In Sweden, the utilities are owned by the municipalities, and how they perform in terms of water and wastewater quality, water and wastewater planning, and so forth. Very interesting thesis. Clemens Klante, he has studied the hydrophysical processes governing brownification for the Lake Bolmen. That is a very important source water for drinking water supply in South Sweden. Björn Almström, he studied nature-based shore protection against ship waves in intracoastal fairways. So that is coastal hydraulic application of research. Hossein, he investigated advanced remote sensing precipitation input for improved runoff simulation, local to regional scale modeling. So he's one of the remote sensing PhDs. He's now occupied with a postdoc, also continuing with remote sensing work. Mehran Nasrirad, he presented a thesis about sustainable environmental cleanup, dynamic assessment for sustainable remediation of contaminated sites. And he investigated how could the cleaning of contaminated groundwater be more efficient if we use smarter algorithms, and also understanding the mix of information about groundwater pollution, load from the sites, and also what vulnerable activities are around that contaminated site. Well, it's a very complex, very advanced problem, and quite little intelligent analysis is done on how to do the remediation. Darin Musabek investigated PFAS, this remediation from firefighting foam remediation that is extremely persistent and is not degraded, and how that spread in groundwater, transported in groundwater, and so forth. We have a quite fine group of research, quite a broad group of research applications. And we are happy also to see what may be of interest for American University in Armenia. And thank you for your kind attention. If you have any questions, I don't know how, Gar, but we take the questions here, or if we take them collected afterwards.
We have 5-10 minutes. If you have any urgent questions, feel free to ask Kenneth. Otherwise, we will have the next speaker, and we will have a short break, and then you can approach any of our speakers to ask specific questions or socialize. If there's anything urgent now, no? Okay. Then we can move to our next speaker, Christian. A quick overview about Christian Alsterberg. He works as a research leader at the drinking water company. I'm not going to pronounce that one.
No, I will do it.
He's also a senior lecturer at the Water Resource Engineering at Lund University. He collaborates with different organizations, entrepreneurs, etc., for drinking water quality, but also optimizing wetlands to mitigate brownification, water balance, budgets for catchment areas, and overall water management. So I'm not going to take much more time. Yes, we can. Okay.
Okay. Yep. All right. Thank you. Yeah. So my name is Christian. I work as a research leader at Sydvatten. That's how you pronounce that. Yeah. And that's a drinking water company. And I'm going to introduce you to the company as well. But I also have the privilege of working at a company, but working with research. So I also have 20% at Lund Technical High School, where I help and guide PhD students in becoming, researchers. All right, so let's get into it. Okay. I think you just need to click something. Yeah. Yeah. No, but it just click with the mouse and that. Okay, so Sydvatten is a joint-owned company by the 17 municipalities that we distribute drinking water to. So we have 17 municipalities. We provide it's about 1 million inhabitants that we provide with drinking water. And for our processes, we have 3 water resources, as you can see here on the map. This is southern Sweden. So we have one fairly large lake up here called Bolmen, and then we have Lake Vomb, and then we have these backup lakes, Ringsjön. So, and we have 2 treatment plants, Ringsjöverket, which is here, and then Vombverket here. So some smart people many years ago realized that the supply of drinking water in this part of Sweden will become a problem at some point. So they realized that we need to provide this part of Sweden with surface water, and they built a 80-kilometer underground tunnel providing water from this lake down here. And of course, you can imagine how much this is a lot of issues. Just this, we are basically stealing the water from them. So we have to work a lot with communication for them to understand how the system and the water balance works here. So we take about 500,000 people are dependent on water coming from this lake, and then 500 from Lake Vomb. And this is more of a classic cleaning process with surface water that you provide that you produce drinking water from using chemicals and so on, and slow filters, etc. At Lake Vomb, we extract water and we produce artificial groundwater, adjust the pH a bit, and so on, and then we distribute it. And then we distribute it to all these towns, but only to the town. Then the town will take over and distribute it to their customers. So we have the privilege also to not have any contact with the actual users. That's up to the towns to deal with. Yeah. All right. So these lakes obviously have environmental problems. Bolmen has problems with brownification, which is a process it's a problem for the lake itself and the ecology, but also in the treatment process, removing organic material. And Lake Vomb, which is basically surrounded by the agricultural landscape, have problems with eutrophication. And each summer we have massive algal blooms, and sometimes they are toxic. So this is something that we also have to deal with. So that's what I'm going to be talking about today. We have a focus on this lake, and this is where we are working with the people that are somehow are working in the lake or around the lake, you know, with fishing or agricultural activities or etc. So basically, it's 70% agricultural land around in the catchment to the lake, and the biggest problem, you know, each summer we have this. I'm sure you can recognize an algal bloom here. And the main cause of the problem is the external load of phosphorus into the lake. But we also have an internal loading of phosphorus into the lake. So with you know, having these problems, people gathered around and tried, okay, so how should we try to solve these problems? And that's when this locally project was initiated called Focus Vomb. So we are focusing on the lake and its catchment only. And so this is the project, and part of my job is to lead this project. And the overall goal here is to work for better water quality and a healthier lake, obviously. But we also want to bring all the stakeholders together and have this increased awareness and knowledge about the lake and the processes occurring in the lake and around the lake, and how we together can have a healthier lake. Because people are using this lake for swimming, recreational fishing, a lot of stuff. It produces drinking water, it's a hotspot for biological diversity, etc. So there's a lot of interests in the lake and the area around the lake. So in order to somehow organize this, we have some kind of organization in how we are doing this. So the lake is located in 3 different municipalities. So we have a board with people from these towns, and those are politicians. So we have politicians, representatives from our company, representatives from the landowners that owns the lake, and some other politicians from another water company. They are the board, and they make the financial decisions, what we want to do within the project. And then we have a working group with farmers, officials from the county, landowners, fishing, like both professional and recreational fishing, and town officials. So this is where the more operative work is going on, where we set up new projects and new ideas about environmental monitoring, etc., and how to fund it. And then we lift that to the board, so we get also the politicians on board with the stuff we're doing. But everything that we come up with is always locally already decided, because we have all the landowners with us when we are having a project. It's just the board with the politicians that also agree on this, but that can also help us in terms of funding different types of projects within or around the lake. So the areas we are working with, some of them are almost done now. We are working with digitalization. There's a lot of old reports that people have an interest in. So we have been searching the libraries, etc., to try to find these reports, digitalize them, and make them publicly available. Trying to understand the ecological status of the lake. You know, we have the EU Water Framework Directive that we have to take into consideration here. Environmental monitoring, fish management is a big issue. Internal phosphorus loading, external, and then we have to communicate this to the politicians, to the town officials, but the primary target group here is the local local communities. So I'm just gonna try, without spending too much time here, try to go into these different areas, how we do and how we work here. So I'm not gonna go into any ecological or chemical details here, but quickly, like digitalization is pretty straightforward. So I'm not gonna go into it, but basically it's around 200 reports that we have digitalized. It's an open source, it's a searchable file. Everybody can go in and search on our homepage and find the reports. And we know a lot of reporters from newspapers, etc., when things are happening in the lake, they go and search for information here. Also researchers. So this is an activity that we actually are done with. But these are some really fun stuff. So current status, considering the fact that we have a lot of algal blooms in the lake, we initiated a collaboration with Lund University and a citizen science project called the Algal Guardians. So people living around the lake were engaged in this project, and we set up different sampling spots around the lake, and had some workshops on how to take samples, so it was standardized. And then they went out every day throughout the period when we have algal blooms in the lake, took samples, filtered them down, send them into the university where researchers were processing them. And then I received that information from the researchers, and we posted that on our homepage. And we have WHO's recommendations for different concentrations of algal, the presence of algae. And we could see, we could, for example, recommend people to not swim in the eastern part of the lake, for example. So it was a direct feedback to the local community if they could swim or not, or if the dog could swim and drink water from the lake. But we also produced a lot of data that we can use for research. Another project that we have been doing that's also finalized now is we have the EU Water Framework Directive, and it's a lot of things to take, to consider when we are working with lakes. And for us, it's the county that kind of that operates this, and we have to kind of obey that. And they are the ones that gives the lake its ecological status, and we all want to have a good ecological status. This lake is far from good. So what we wanted to understand is, why isn't it good, and what do we need to accomplish in order for the lake to have a good ecological status according to EU waterway directives. So we could identify knowledge gaps and try to understand this, and then also improve our communications with the authorities when it comes to having the status for the lake. So we had these graphs, for example, what do we need to accomplish depending on the different factors, water quality factors. So we could know we need to have accomplished a visibility of X amount of meters in the lake. That would help in, managing to have a good ecological status. So we published that report, and immediately we had a negative response from the authorities, right? Because all of a sudden, our company was more or less criticizing the authorities. So we were controlling them; they were not controlling us. So this is not actually the purpose of the project, and in the end, everything was actually great, but it was a bit of a turbulence a while, let's put it that way. So what happened what happened after everything was done here, right? We had a revision of the environmental monitoring program in the lake. We have improved management, and this will also induce a lot of other projects I'm going to talk about. Now we are reporting all of the data to national data hosts. This was not done before. This was something we identified. And we have actually improved our knowledge and discussions with authorities, because they realized that everybody wants the lakes to be as healthy as possible. And after this turbulence was like kind of settled and we agreed, we actually have an increased engagement from the county with more funding to the project to do stuff. So it was worth the fight, let's put it that way. Right. Environmental monitoring. This is actually in Swedish. But what we actually did, and this was also the report that kind of pushed our project to have a look at this. So the lake, considering how valuable it is, was actually not very much monitored. So within the project, we actually compared the lake with other lakes in terms of environmental programs. And we could see that yes, there was some environmental monitoring going on, but mainly on a yearly basis, once a year in August, for example, which is far from good. So having all that information and the previous report being published, we actually revised the entire environmental monitoring program. So now we are actually measuring each month now. So we are now actually monitoring the water chemistry, chlorophyll A, visibility, macrophytes on a regular basis, building up a database, finally having, so we can see some trends for the lake. This was also the project that pushed this, and we pushed the politicians in the different municipalities to fund an extended environmental program and monitoring program, because they don't always understand the purpose of doing environmental monitoring. So we had to explain to them, show them these graphs, like, look at this. This doesn't make any sense. This is a drinking water reservoir, and it's less and monitored than other lakes in the landscape. And we are also doing right now some in-house environmental monitoring. We are using investigating the bottom using echoloads, using echo sounds, etc. Here we can see where we have vegetation in the lake, and how much there is, and better depth profiles for our hydrological models, and also sediment hardness. We can see where we have accumulation of sediment, which might be of interest in terms of internal phosphorus loading in the lake. All right, so my apologies for this picture, but I usually use this one, clipart thing, when I talk to politicians. And the reason is that fish management is one of the easiest way for us to improve water quality in the lake. And people, I always get asked, why are you spending so much time on fish management? And it's actually fairly, and then I show them this picture, like everybody understands this picture, I think. And this is the reason, like, because we have around 13 species of fish in the lake. And they have all like different functions in the lake. This fish loves to eat that fish, and also this one. So there's some kind of competition right now going on here. But this fish also eats this one. But this fish loves to eat the phytoplankton that blooms in the lake each year. So somehow we need to make sure that the professional fishing going on in the lake is positive for this guy, which means that we need to fish more on this fish. But not, because that fish actually also, then the negative thing is that this fish eats this fish that are actually, searching for food in the bottom and can contribute to release phosphorus. So it's very complicated, but we can easily target some species that we need to control through fish management, and that can actually help the water quality in the lake quite a lot. So yeah, I'm gonna skip this one, but we have identified what we need to look more deeply into. But what we did was and this was basically really like together with everyone around the lake, mapping of the fish community. What kind of fish fauna do we have now? We got all the data from the professional fishing. We did a lot of standardized test fishing, electrical fishing, eDNA, and the effects of cormorants. Do you know what that is? Yes, we don't like them. Look at that. It's like having a professional fisherman that just goes bananas in the lake. So we have around, this is a problem for us right now. We have around 600 individuals in the lake each day. And each of these birds can eat, from 0.5 to 1.5 kilos of fish per day. Just going bananas in the lake. And this is a huge problem. They can devastate an entire lake. So we did a summary of previous test fishing. We interviewed current and previous fishermen in the lake, and how they have experienced the fish community throughout the years. Did a lot of test fishing together with the fishermen. We got a lot of data from the fishermen, summarized the development of their professional fishing since the 60s, and how the changes in the fish, the type of fish that they caught compared to other environmental parameters in the lake. And then we used all that data, sat down together with experts from the county and the university, but all the landowners, fishermen, etc. And together we wrote a management plan for fish and fisheries in the lake. And this is now implemented in the lake. And it helps us improve the data collection, and we have reduced the number of fish that for recreational fishing. Professional fishermen right now are targeting some of those fish that we want to remove from the lake to improve water quality. And it's never been a problem because we have done this together from the beginning. So once this was implemented, everybody already agreed on what to do. It was basically just an exercise for everybody in and around the lake to do it, to realize that what we need to do. And this is one of the projects that we identified within this management plan in terms of measures for improving fish playing areas, like areas for reproduction. So we have a large area here. We have this project area here with some grassy areas for cattle to graze. And then we have some ponds and some good areas that could be flooded. And together with the landowner, we have agreed on taking care of some migration barriers and constructing wetlands. So we have some migration barriers. If we can just fix that somehow, fish can actually use all this entire area for reproduction. So this is what we're doing right now. So these are some examples, and we're going to start construction in the fall. So we are building a huge wetland for fish wetland. I'm going to show a picture of that. And here's the migration barrier right there. So we're building a path around that barrier, allowing all fish to enter this area. And we're going to build more of these fish wetlands upstreams. In total, like 20 hectares of wetlands for fish. And this was also very easy to do because the landowner is part of the project. So this is how a fish wetland could look like. It's only flooded during winter and early spring when fish reproduce. And then it dries out, and the landowner can use this area for their cattle or for their animals. So it's a win-win. All right. So then we have some problems with internal phosphorus, like old stuff that's been in the lake, and we have just started to have a look at that also together with the people in and around the lake. They are helping us with measurements for oxygen, for example. So we're out doing oxygen profile measurements in the lake throughout the summer periods. We have started to look at models for internal phosphorus loading. We are sampling the sediments and fractionize the sediment for identifying the mobile phosphorus and so on. I'm not going to go into the details here, but and also this is also something we did. We looked at when do we have stratification in the lake and what kind of concentrations in the lake do we have, because this is a trigger for internal phosphorus loading. And these are also measurements that's been done together with the locals, driving the boats, etc., taking out our staff, helping us with the measurements. So here are some results. I'm not going to go into, but we can see when you have no oxygen, then the bottom water total concentration of phosphorus just like explodes, and then it triggers an algal bloom basically. All right, I realized that this one should be here. So external phosphorus loading. We are, as you can see, we are building some wetlands, but this is some really cool, fun stuff we are doing right now. In dealing with external phosphorus loading is tricky. Basically, what we want to do, we want to build and construct wetlands in the catchment area. And by doing that, we are in direct need of the landowners because we have to use their land to build a wetland on their land. So doing that is a tricky process because somehow they need to see the win-win situation in this. So what we are doing to tackle the external phosphorus loading in the lake, we are doing these water dialogues, water conservation and environmental monitoring. So water dialogues is basically what we do. We identify an area in the catchment where we have a lot of phosphorus and nitrogen concentrations. And we are forming a kind of water group. We try to find some engaged local landowners, and then they talk to their friends and other landowners, and all of a sudden we have maybe 30 people. Then we have a starting meeting with them, and we sit down together with officials from the town and the county. Sometimes, not always, because sometimes this is actually a threat to the landowner. If they know there's people coming from the county, they don't want to attend to the meeting. So sometimes we have a startup meeting without them. And then we have lectures and discussions. And these lectures and discussions are based on the interests of the landowner. So if they want to know how to improve irrigation, we have lectures about irrigation. So they are the ones deciding what we want to talk about. Then we do these field tours. We look at maps, and we do local sampling in streams. And that's when the work kick in terms of water conservation. I'm going to show that here. So dialogue instead of information. So we try to have these dynamic discussions with the landowners. Everybody is entitled to ventilate their opinion. And when we are looking at measures for wetlands, etc., they are always discussed together with landowners on site, so on their own land. We never approach them and tell them we should build a wetland here. Basically, we want to try to trigger so the entire idea about building a wetland comes from them, because they have maybe a piece of land that's always wet that they cannot really use. So it might be better to build a wetland there, and they can get some financial funding for that. By doing this process, we have seen that we have this understanding what the landowner wants and what we want, and we understand each other, and then we can get the momentum in the building of wetlands in the area. So far we have done more than 200 participants. We now have a common view of knowledge, and we are improving water quality. These are some of the wetlands we have constructed. In total, I think we have since 2015, it's around 25 wetlands in the catchment area. And all of them comes from initiating a water dialogue. And here's also the thing with this project, because we have some big landowners in the project, and they are kind of setting the pace for the measure work we do. So the smaller landowners to see they can see what they are doing, and then they want to do the same thing. And then least communication. So that it's hard to get people to be interested in what we do. So I have adapted the last couple of years is that instead of having boring information meetings where we just pump them with information, we have a theme, a thematic day. Each year a new thematic day, and that actually brings more than, we have around 100 participants each year, and they are basically every social media, newspapers, etc. Yes, but most of the people sitting here are locals living in this area, interested in what we're doing. So last year, the theme of the day was a taste of Lake Vomb. So the professional fishermen came with the lake that they've been fishing from the lake, and we served that at the information meeting and discussed and informed them how we are dealing with fish management right now. And then we had bread and meat and so on. That was from the farmers around the lake. And we talked about the wetlands we are doing and how this is improving water quality, and that we are doing this together with them. And here we have Professor Karin Rengefors talking about algal blooms, and that not all algal blooms are harmful. They're also necessary for the production in a lake, and gave some summary results about this citizen science project we did. So by adapting this approach, people are actually already now contacting me, like, well, what's the thematic day for this year? And the thematic day for this year is the lake Bombkön is blooming. So we're going to focus only on algal blooms, and they're going to be able to look in microscopes and all these things. Yeah. I think that's it, actually.